So hello, my name's Chris Wade, CTO with Itential.
And I'm Alex Degitz. I'm the product manager of our core Itential platform.
Awesome. So we're going to talk a little bit about the network applications. So we talked quite a bit about how we integrate things. A lot of great questions about abstraction and federation, and how are we a power user of the network without restricting your ability to continue to use those other platforms, so we don't create this stacked architecture. So we're going to talk a little bit about network applications, and I started within the architecture talking about these network applications should feel normal, like these are things we do on the network. But before we jump into the demo of, I think we're going to show Configuration Manager, I want to talk a little bit about rethinking about the way we think of an actual network element. So I think this will be fairly familiar to people. Most people think the configuration of a network element is like 2,000 or 3,000 lines of CLI, right? Show, running, config, blast it down. The device is that. But in reality, if we think about creating it, being a little bit more modular, we're using a lot of software words today, but if we break this down, we have basically a couple groupings. We have a piece of hardware. It could be physical. It could be virtualized. It has some sort of operating system that might be part of some immutable infrastructure if it's virtualized. But really, this CLI breaks down into three main components. So our day zero through day n terminology, if I can use that, is really what's permanent on that box. So when I set an NTP server, I don't expect to change that unless I actually change my NTP server. That doesn't happen very often. Hopefully my passwords are on rotation, but we're not changing it too often. My host name, there's certain things that don't change very often. That's when we think about NCCM platforms, when we think about doing compliance reporting, making sure there's no config drift, most of the time that applies to config that's not supposed to change that much. So if we rethink how we do configuration management, we can think about creating hierarchies. We can talk about having inheritance models, and Alex is going to demo how we do that with Configuration Manager. But my host name and my services are quite different. So whereas I expect my day zero through day n configs to be fairly persistent and not change that much, they'll drift over time, but hopefully within what I want it to be. My services are going to be changing all the time. And if I'm a top-of-rack switch, let's just stick with the configuration management for a minute. I might just be a top-of-rack switch and I have a certain set of configs. And then I might be a top-of-rack switch in a certain data center, which means I have something specific to that data center. And then I might be a top-of-rack switch for a Hadoop big data cluster, which means I get very specific configs. So every config of every top-of-rack switch might have certain configs, but being a Hadoop data, I might have very specific configs based upon that application that's in here. So that's all going to be kind of inherited in configuration management. We'll get that into it a little bit more. When I get to the service tier, that contains IP addresses, VLAN assignments, all sorts of funny stuff, so that it's only for me. So my service configuration is only good for me. It's not good to anybody else. So how I manage configs that are day zero and how I manage service lifecycle is very different. So instead of thinking about it as 2,500 lines of regular text, we start thinking about taking out different chunks of this and treating it in different ways. And the last one is policy. So whereas service is very specific to my device, and I think day zero through day n is fairly generic and applies to lots of devices, policy is somewhere in between. So if I set up an ACL, that ACL might be on a lot of devices, but not all the devices. So I might change that policy one time and want to push it out to a lot of places. And the reason we think it's very important to think about segmenting the device into these components is that over time, it's not going to be CLI anymore. So some of it might be CLI. Some devices, it's a JSON object, right? And we still want to convert everything to a CLI, but the native interface, we talked about Viptela earlier, pushing policy, pushing configs, deploying a service, these are native JSON elements. So if I want to start thinking about managing a network element or a set of network elements, it helps to break it down, because ultimately, this has a lifespan on it in the sense that the native way to configure different objects are not going to always be the native CLI. So when you think about the applications from an Itential standpoint, we have three core applications at that application tier you saw before: config manager, service manager, and policy manager. And those are really thought of from a software practice as an IDE, as a way that's purpose-built for you to manage the lifecycle of those things, because they're very different, as will evolve over time. And we'll show a demo of the config manager.
Actually, before you go on, I'll preface this with, this may be me being entirely picky as a network engineer.
Sure.
So I'm looking at the config and where you've got your little lines drawn, and my first thought is that each day, if we're separating things that way, I may have one interface that has different pieces. You know, this config done on this day, this config done as part of a service, or as a different day.
Yep.
Are you saying that the interface belongs to day one because that was the last change that it did, so that entire interface config goes up there? Or, I mean, is this just an example and you just say, Scott, just shut the hell up because we'll get further?
I won't say that part, but the
But he'll think it.
You might deal with that.
so I'll pause it for the demo. So the idea here is less about which day it's on. It's about you as a network engineer being able to configure the inheritance model and the separation of what is day 0 through day 83, if you want to have 83. Most people don't have 83 days. But the level of inheritance is dependent upon how you configure your network. Because at the end of the day, the idea is you should only define that config one time. The issue historically is we've defined like 85. I have 85 golden configs of top rack switches, and like, how do you have 85? Like, they're not golden anymore. Well, this, the big data guys needed this, and these people needed that, and then something comes out and says, hey, I got to change something that's fairly global in nature. I want to, some vendor told you that, or some sort of planning team decided we're now going to implement this for security, whatever the reason. You got to go change it in all 85. And then you got to figure out which devices are attached to that. There's a much better way to say, hey, where in the hierarchy is it defined one time? I'll change it there. It'll inherit to all the golden configs that apply to those thousands of devices, and I can do it, and I can manage it that way. So that ID that we're going to show you, so it's the short answer is it's completely configurable by you, and we'll demo it in a minute.
Okay.
So after you have those applications defined, the last step that we're going to show today is the Automation Studio. So what that is we've talked about adapters, we've talked about brokers, we've talked about network applications, we've talked about these federated views. These are all services. These are all API calls that are available to you. Now we need to coordinate these activities. Maybe I need to open a ticket. Maybe I need to get an IP address from an IPAM system. Maybe I need to coordinate that with another team. Maybe I need to find out what the real-time access is. Maybe I need to get telemetry state. Maybe I need to get operational data. I need to coordinate these activities for a change. And these are the sets of capabilities we have to do that. So real quickly, the form builder application, we've talked a little bit about data models, Tosca Yang. This basically allows you to build aggregate data model from those underlying data models. So you have data models coming from the orchestrators. I might need to take, back to the example we used in an ANZ presentation, an SD-WAN data model, an orchestrated data model, a DevOps data model, and create a superstructure that is now presented northbound to an abstract user that doesn't need to understand that implementation detail. This form allows you to drag and drop and create those so an end user can fill it out, or it auto-generates an API, and you'll see that in a second. Template Builder allows you to do things like Jinja templates and TextFSM templates and all the templating logic that network engineers like, so that we give you the engine ability to do that natively in the platform. Command templates allow you to collect operational data, show commands, telemetry data. When I'm making an automation decision, I need to go understand right now, is it okay for me to do it or not? And I know I'm talking fast so we can get through. So the workflow builder is how we have the actual canvas. So you'll see Alex design a workflow, the canvas of actually dragging those on, which data comes from one to the next, what happens if something goes bad, what happens if I want to retry, how do I loop, how do I do child workflows, how do I create the automation logic around those systems, and ultimately they get published in an automation catalog. So the team might be working on a lot of automations. There might be an application team that says, I want to be able to change DNS and load balancers, and I want specific things. We can publish out those capabilities back through some of the RBAC discussion and security concerns we had earlier, so they only see the workflows and the automations that we expose to them in a controlled manner, and then they can execute them on their behalf. Because ultimately, everybody expects some level of self-service. Hopefully the spreadsheet email requests for network changes are coming to an end. Yes?
So do you do stuff with, like Github Triggers and things like that, to the point where, like, if I've got a code repo for all this stuff and I've sort of abstracted everything to where I've got a password stored somewhere, an SSH key, and I've got, maybe it's in Vault, and I need to make a change to something, or change the DNS address of some server somewhere, and I check that back into my code repo, and then now it's going to trigger, and every device that's pulling variable for that is going to update. Or can you do stuff like that, or have you seen people do that?
So we're going to do 2 demos. The first one is without any Git at all. So that means we build it in the way you've seen, we process it, we pre-check and post-check it, stealing a little thunder here. Make sure we don't think. Make sure we're not we're not going to break anything, and we deploy it to the network. That's broadly how we do it today. Second demo is going to be introducing Git as a pipeline in between. And when you do that, you can choose to just make it. You can either build it through this mechanism, or you could go directly in the Git repo. It has a Git hook back, and we deploy it in the network just to steal his thunder.
Okay.
So with that, I think we'll just jump into the demo.
Awesome.
And I'll give you a time check.
Okay. So yeah, I will demonstrate a couple of our capabilities. I'll start with the app configuration manager. We've already seen it in Anand's demo, where he looked at devices that we federated from our broker. I'm going to focus on the golden configuration part in this demo. And what I see here is our golden configuration section. We can create a new one, and we can choose the OS type of the config that we want to choose for that device. But I also have a preloaded one. For that, I'm just going to grab a different server. Sign in. Exactly, here it is. So I've prepared one for a CSR 1K device. And what we see here is basically a configuration tree that we've created for CSR 1K devices. And what we see on the left side here is our inheritance tree. So we have some configuration that is really basic to all of our devices. So for example, in our example that we see in many customer production environments in a similar fashion, is we want to make sure all CSR 1Ks that we deploy in this tree should be on the software version 16.10. Now we get a little bit further. We actually look at some day zero configuration. And here we have some timestamp configuration, some platform configuration, some logging configuration, something that we want to have on all of our devices. Let's take this chance to quickly look into the configuration editor. We see we have like the parent-child relationships of, for example, the RF definition. We have child elements underneath. And for example, in our normal settings, we say the golden config that we define here, of course, that should be required on a device. We could also ignore certain sections, we just gray them out. Or what is actually really powerful in production is we can say this config should not be on any device that we have, and that could be like some routes that our security department says this is not allowed anymore, something like that. So we can also make sure, make the negative test, so to say, that some config should not be on devices. And we can choose the error warning or info, that's just a severity level, if a device does not comply to our golden configuration. And as I drill in further, our day one, I don't want to make any changes right now. In our day one configuration, we could have, for example, for the US, we could have some configuration for our east routers. So based on location, we could say east, central, west, or also in Europe, we can have some different configuration. And to go back to the day zero, day one config, we can absolutely add some interface information in day one. We can add another interface description or another IP that we set in day two, day n configuration. Both of that is possible. We see that here for our host name. Of course, we cannot have a host name in the golden configuration, but what we can do, for example, based on the region, we can make sure that it starts with a certain regex. For example, all of our East Atlanta devices should start with ATL, and we can make sure that they comply to this naming convention. Same we can do for descriptions and stuff like that. And so for our device management, I've created a device right now here that is in full compliance. We see that in our blue bar here. And to quickly go back to the power of this application and other applications as well, for that fact, is I hope you've seen a lot of these concepts that I especially show in the config manager part of the demo. You've seen those at other NCCM tools. Like, this is nothing special that we're doing here, but the way we're doing it is very special and very different, because these NCCM tools usually have this vertical integration, direct device drivers, direct device connections. Config manager does not know anything about your devices that it didn't get from the specific system that it's integrated with. So it does not know when we say add this core VNF device. it does not know, or it does not need to know which system that is deployed on, how we integrate with that system, if it's through a playbook or through a direct SSH into that device. We're fully agnostic of that. So what I'm going to do now is just run through one quick scenario. And let's say our security department comes in and says, like, hey, we have a new policy. We need to make sure all of our CSR 1K routers only allow SSH version 2, for example. SSH version 1 has certain security vulnerabilities. And I mean, for some of our customers, that could mean they need to change and check 100,000, 10,000 of routers to make sure this config is on there. For our iOS example, I can just say IP SSH version 2. What that means is basically, if that is set on the device, I make sure that it does not fall back to SSH 1. I can only do SSH version 2. So I save this config and actually run the compliance on my ATL branch 15 device. And what it does here, again, it asks the broker, hey, get config for this device, but I don't care how I connect to it. I'll just retrieve the result and check it for compliance. And if we see the latest report here, we see we have now fallen a little bit out of compliance because the required config, IP SSH version 2, was actually not found on that device. What I'm doing here on the UI, running that compliance report, and what I'm about to do, remediating that compliance, I can as well do through an automated API call in Workflow Builder, which I'm going to show in a second. So actually, in a full-fledged customer environment, I would have already been done by changing the day 0 config to include IP SSH version 2, and then let just the automatic scheduled compliance report and remediation, let that pick up the change and have it deployed to my network. But now I changed it manually just to see. My remediation was successful. And if I were to run another compliance report on my ATL branch device, we can see that it is in full compliance again because we have pushed that change onto the device. If we look again at the latest report, we see we're at 100% again, score 100, and we have pushed that onto the device. Let me move on to show you how that actually works in our workflow builder. And let me actually start with a completely fresh workflow. And let's say we have some integration with Viptela. Let's say we want to create an automation that resets an interface. That is something that, of course, you can do in Viptela by selecting the device and in the UI, click the button, reset interface. But since we've, in our adapter wizard, automatically created a Viptela adapter based on our based on their Swagger doc, we have that call available in our workflow canvas here. So if I were to search for reset interface, we see the call here, and we can just drag it on our canvas, which is basically the API call from the adapter we have just discovered.
So just a question about this, because it seems like one of the things that you guys are definitely being very conscientious of is that, especially in network engineering, we're in a space where there's a lot of people that are coding now, but there's definitely a whole large group of people, myself included, that have not done coding traditionally. We've been on the CLI for a very long time. So it looks like you can interact at the code level with your product if you want to, but everything seems to be oriented towards engineering teams that have not been introduced to DevOps concepts, and that you're trying to push that in a graphical, easy-to-use format. Is that?
That's exactly what we
that
want.
seems to be very much at the foundation of what you're doing.
Exactly. That is our definition of low code, is get as many people involved in defining what our automations need to look like as possible. We need the knowledge from network engineers. They know the network. They know what commands, what things to execute on their network. But we also need software engineering principles to make sure these automations stay maintainable, readable, reproducible, or reusable for other use cases. So in this workflow builder, we're trying to allow network engineers to build their automations while kind of like enforcing good software engineering principles while building them.
I think this helps with smaller shops too, who now automation isn't just for a large enterprise architecture. It could be a smaller business or even a consulting firm who doesn't have a dev on hand.
Yes, absolutely. So let me move through this a little bit. So we have this Viptela call, and we could literally just say, this is our workflow. Now I can do it through our automation. We have it API enabled. We could schedule that at some point rather than logging into Viptela and doing that. But in the real world, that's not everything you have to do, right? You may have to open or process a Jira ticket or a change request ticket. You may have to run a pre-check to see if that device is actually able to receive a command like that. So for example, we could run a command template, which Chris mentioned shortly, to do some pre-checks of like, what is the network status of that device? How many network connections does it currently have? What is the CPU status? Stuff like that. And based on that, we can make a decision if we say, do we want to move forward, or do we want to like show the user some information and say like, hey, this device is not ready right now. Let's say that worked though. The run command template was successful. Before we want to change anything on that device, we probably want to take a backup of it. And that's another really powerful call that I want to show. It's just like backup device is a brokered call. And when we call that, all we do from Workflow Builder is tell the broker, here's a device name, take a backup. I don't know anything about that device, no connection info. I'm just telling you, do this, figure it out, and give him back like an okay, yes, I've taken a backup of that. So that's what we can do here. And what we can also see is how do we actually do this? So I'm drilling into a task, and here we see basically a visual representation of the API call that we're using. We have incoming variables, or parameters, outgoing parameters, and error conditions. So here with device, we have the device name. We could, of course, just say, hey, I'm going to use a static device name, say like my device. But I can also use a job variable and say like, hey, I have provided a form, for example, before I kicked off this automation, where a user had to like drag and drop and select the device that I want to reset this interface on. So I can just take that information rather than hard coding something, because I want this automation to be as reusable as possible. So I select devices here. We don't need any options. And to just quickly finish that up. And so what I'm saying is, in all of these states, I can just run my automation. And if I realize, hey, after I reset that interface, I have to do something else on Viptela, I could add this task afterwards and do that as well. So it's not we don't have to just build the full automation and then say, okay, this is it, I'm done with it. This can grow as you gain more trust, as you gain more integration points, you can add them to your workflow. Okay, and now let's look at one more thing, just because we just mentioned the developer part of it. So for example, whereas this was like very low-code, network API focused, we also have like a for each task, for example, which is a purple task here, in which you could do that for a device array, for example. All you would need to do is you would start with the for each task and then create a loop transition to do all of this here. So this is basically these three tasks are now in our loop, and then go from there to the end, and we can do the same operations on an array of devices.
What kind of safety features do you have built into this? You're doing destructive changes, or you make a mistake and you've lost access to a large part of your network. How do you reverse that?
You read my mind. That was my question too.
So there's a couple of different answers. So first of all, you can design your automation as you want to have it. Like you can say, deploy this on a test device, for example, and see if that change worked. You can say, make a pre-check and a post-check, view the diff of the config that would be on that device, and then do we want to proceed or do we want to revert back to that step? That's something you could do. Michael, in a second, will show you a little bit more of our infrastructure of code approach, where we can actually do test and validation steps before an actual deployment. There's different ways we can solve this, depending on the systems that you're using.
Okay, and before you get there, I have a follow-on question to that. Is there like a workflow built into your tool. Generally, if you've got a junior engineer making changes, you may want to have changes approved by a senior engineer or hooks into your change management system, say ServiceNow or some other tool. Do you support options like that before I say a junior engineer can push out changes?
Yes, there's two ways to do that. First of all, we have pre-built automations that you can download from our open source developer site for portrait up, software upgrades, like common use cases that we've already published. And building these automations in Workflow Builder is a design kind of task. You do that in your test environment, you figure stuff out, you kick it off, you see if everything works. What I'll show you actually like in a second, so I'll table that for a second. We also present that in our automation catalog with like group-based access control, where we actually make sure, like your superior, for example, would set up the automation and make sure it's available to the right amount of people and can see that he's reviewed everything, that it works correctly. So really quick, I'm running a little bit over time. So this is how a little bit of a more complex workflow looks like. I'm not going to go into much detail, but what we see here is we have some Jira integration. So we kick off a branch deployment. So what we want to do here is we want to set up an EC2 instance, bring up a new EC2 instance, deploy some day 0, day 1 config, do a pre and post check, make sure everything works, and also set our Jira ticket change status to make sure, this change is tracked in our ticketing system. So we create this Jira adapter, so we create the Jira ticket. We build the EC2 instance, waited for a second for that to be done, and we push the configuration onto the device through Configuration Manager, which I've showed earlier. And now I come to Automation Catalog, and that is basically our productizing, the productizing of our automations. These are two, like this is a self-service portal for network engineers where an automation like branch deployment, which I've just shown, is actually set up for you to use. And what we have here is you can do your role-based access management, access control, where you can say, hey, only engineers of these groups can actually run or change this automation. I can then select the form for my EC2 instance. For example, I have a form where I choose the name and the size of my EC2 instance that I want to create. And I can also schedule this automation or run it manually right now. And run manually is actually what I'm going to choose now. And what we see in our active jobs view is we actually now see that this job is running. We see the task with the blue outline is the one that's currently being worked on. So we've already created our Jira ticket and set it to in progress. We're doing a pre-check right now. Is the device ready, or is AWS ready to accept changes? What we see when I refresh my Jira page, see we've run that 1 or 2 times. We see we've created an 80273.ticket, and it's in progress with creating our new branch. So that's something we've automatically created right now.
So in the deployment here that you're doing to AWS, are you showing an example of the actual prod deployment, or was this the validation that you were talking about where I'm going to deploy to a hardware, but I'm going to test this against an instance in AWS?
An actual production deployment.
Okay, gotcha.
So here's a question. Can you guys be, I mean, I hate to, automate the automation tool, but, the use case I'm thinking of is if I don't have something built, maybe it's a demo environment or maybe it's something I tear down and bring up quite a bit, development, something like that. And so I'm using something like a Terraform to actually build out an AWS or Amazon, infrastructure or GCP or whatever. And I want to build that infrastructure, then trigger pre-built, this is all pre-built and pre-canned and everything like that. So I trigger this first, then I trigger that, or you guys to then actually go out and configure it, as opposed to now where you might just use, Ansible or something to do that same thing. You can actually use a more robust tool here.
That is absolutely possible. As Chris said, we want to use the right tool for the right job. So if you use Terraform, for example, we have a Terraform adapter, which
so you can just do it that way.
You could do it that way.
Yeah.
But we could also invoke it. We could also say, hey, we wait until the Terraform instance that you have specified is up, and then we do our thing.
Okay, perfect.
So both would be possible.
Yeah.
And real quick thing. So we go back to the visualization. And this is a completed job because spinning up an EC2 instance and deploying the configuration takes a little while. So I'm just going to use the one that has already been done. We see the tasks that have been executed. And these blue tasks, which I have not shown so far, these are actual manual tasks. And this is whenever we have like an error condition or whenever we want to showcase something like, as I said, we have a pre-check, post-check. Here's our diff. Are you OK with that? Should we go forward with that change or should we revert it? That is something we usually have at the end of the workflows. And that actually brings me to the end of our demo. And I'll hand back over to Chris.
Do you have a community site that has common workflows people can share with each other?
Yes.
Nice segue.
They really did practice.
So I'll forego most of my time just because I want to make sure we get to the infrastructure as code demo. But just real quick, on the developer hub at developer.itential.io, the idea is that Anand talked about the adapter library that's out there. And the adapter builder is a service running in our Kubernetes cluster. So it's a service that you guys can use to build your own adapters. In addition to that, we have the interactive API docs. So everything's on the developer site. To specifically address your question, the device turnup use case as well as the compliance use case are both what we call pre-built automations, and they're published on our GitLab open source repo, so any customer can download and they use that, and you can see it with the documentation out there. So that's a good place to check it out. The one other thing I'll add before we move to the next section is we have this concept of API services. So with these applications, when you think about an application that's got two pieces, we talked about the IDE, and you saw Alex navigate that and make changes to the config manager. Behind the scenes, those apps also have a back-end service, and we call them engines. So we've actually taken some of those engines and we're offering them as services off of our developer hub. So if you want to do CIDR block compression on your ACLs, or you want to have a Jinja service from our library of Jinja templates, and these are useful even if you're not using Itential. So if you're a Python developer or you're an Ansible developer and you're like, hey, I need to access this library of things, I'm making a change to my ACL, we're exposing some of our internal capabilities through these services. And so these services, along with the adapter builder, are running in our production Kubernetes cluster. All you do have to do is register for a token, and they're there to use by the community. So between the documentation, the examples, and then the API services, we think on the Dev Hub, there's quite a robust set of things for folks. Yes, sir.
On the question on the pre-built automations, are you guys actually looking at the next stage, which is really, at least for me, looking at what you have from a workflow perspective, emulation, so that you can go and validate everything across? So like, if you re-emulate a good portion of your network, you want to be able to just address across that, passes a validation in the workflow pipeline check, and then say like, go ahead and push to production because I passed. If you see Dave's presentation at the Network at Scale event, right? He was talking about what Microsoft's doing with their open network emulator.
Yep.
They're taking everything that they have in Azure and actually running all their network network resource devices, not for throughput, but just for validation checks, and then running that in Azure and actually then validating all their configuration changes before they actually push to the rest of Azure.
Yep. So we'll tape, I think the next presentation is going to address maybe 2 or 3 questions we've tabled, but there's static code analysis tools now, which are pretty awesome. And then you have emulations and virtualization environments where you can simulate the changes you're making, depending upon the scale that you think you require. And I think Michael's presentation should directly reference that.
Okay.